All right, we've got a straightforward thing going on here. Um, we're doing the converse of these particular theorems. Remember, we found out that um, if we are dealing with a rhombus, then we're going to have diagonals that meet each other at 90 degrees, right? They're perpendicular diagonals. Well, the converse is also true, that if we already know that it's a parallelogram, and we see that the diagonals are coming at each other perpendicularly, we can conclude that it is a rhombus, because it's only going to happen if it's a rhombus. Okay? It's a converse. So yeah, here's a proof of it. You can take a look. I'll stop the video and you can read through this. Um, and yeah, there you go. Okay, a couple other converses here. We know that if a parallelogram is a rhombus, then it is going to bisect, the diagonal will bisect the opposite angles. Um, and the converse is true. If we see that those angles are bisected, then we know that it is a rhombus. Okay. Worth noting here that it says if it is a parallelogram. So if we have a parallelogram, we're starting with that, then we should have opposite angles congruent, which actually means that this angle, angle ABC, is congruent to this angle ADC. So when they're both bisected, we really could put a single angle mark on all of them. They're all going to be equal. That's just worth noting. Now, we know that if we're dealing with a rectangle, then the diagonals are going to be congruent. Okay, so the converse is also true. If we're dealing with a parallelogram and we have the diagonals congruent, then we can determine that it's a rectangle. So we're going in the other direction. We're not told it's a rectangle and then saying we can conclude the diagonals are congruent, but rather the converse. Okay. Okay, so you may have noticed in the lesson objective that it said we were trying to classify a parallelogram as a rectangle or a rhombus. They didn't mention square. Why didn't they mention square? Well, if we can classify it as a rectangle and we can also classify it as a rhombus, then it is a square. And so really we're looking for the features that would say that it's a rectangle or a rhombus, and or, because if it's and, it will be a square. Okay. Now, this just notes here that we're seeing if we want to know whether it's a special parallelogram, we're seeing whether it satisfies all of those conditions that would define them as such. Now, can we conclude that the parallelogram here or here is a rhombus, rectangle, or a square? Explain. Well, we see that we've got the opposite angles bisected. And recall from the theorems that we just went over, if opposite angles are bisected, then we know that we are dealing with a rhombus. Okay, so the diagonal bisects two angles, therefore it is a rhombus. Okay, what about here? Well, we see that this has diagonals that are congruent because all parallelograms, their diagonals bisect each other, but we have equal amounts here and here and here and here, which means that the diagonals must be the same length. What kind of figure has diagonals the same length? A rectangle does. Okay. Now, we also know that which kind of figure meets the diagonals meet at 90 degrees or perpendicularly, that's a rhombus. Rhombuses do that. So we have features that meet the rectangle specifications and the rhombus specifications. And so if they meet both, then we can classify it as a square because it is both a parallelogram, I'm sorry, both a rectangle and a rhombus. Yeah? So what about this got it problem? See if you can do it. Start off the video after you got your answers down and see how you did. So let's take a look at this. For what value of x is parallelogram ABCD a rhombus? Well, we know that a rhombus is going to have a diagonal that bisects the angles. So there's going to be some value of x that's going to set this amount equal to this amount, okay? For it to be a rhombus, the diagonals must bisect a pair of opposite angles. So that angle ABD must be congruent to angle CBD. Okay, so you set them equal to each other, you solve it out, and that is the value of x. That would make them equal and therefore make this figure a rhombus. Yep. For what value of y is this particular parallelogram DEFG a rectangle? Think about it, solve it, and start the video to check. This is a pretty slick real life trick with these concepts, okay? Builders use properties of diagonals to square up rectangular shapes like building frames and playing field boundaries. So suppose you're on the volunteer building team at the right, and you're helping to lay out a rectangular patio for a youth center. How can you use properties of diagonals to locate the four corners? Okay, you can use these two theorems. First one says that if the diagonals bisect each other, then the quadrilateral is a parallelogram, okay? And if the diagonals of a parallelogram are congruent, then it is a rectangle. So what do? Well, this is how you do it. You say, okay, first we're going to cut two pieces of rope that will be the diagonals, and we're going to cut them the same length because we want them to be congruent so that it's a rectangle. We need to make sure that they join at their midpoints because from theorem 611, if it's a parallelogram, they bisect each other. So we join them at the midpoints right there. Okay, they're the same length, so we know it'll be a rectangle, and then you pull them straight and taut. And the ends of the ropes will be the corners of the rectangle. Yeah, pretty neat, right? Now, question for you is, oops, sorry, I'm having a little trouble. Can you adapt this method slightly to make it be a square? Okay, think about that, try and explain it, and then restart and check your answer. Okay, we've got a pretty straightforward lesson here, hopefully. Converse of some of these theorems we used in the last lesson. And try these lesson check problems and see whether you get what's going on. Okay, good luck with this.